Okay, good morning. We start our morning to talk about irrigations and irrigation system. So first of all, can you go one ahead? I want to say that we are handling a lot of irrigation projects in West and Central Africa. So Crop20 Hungary is supporting Kumasi, Tamale, and Iken. Supporting means they are sending some money. And as well, we are designing projects in Nigeria for Ibadan and Kano, and for Senegal and Ivory Coast too. So these other projects, we still try to get the funds, and we're fighting a lot of this. I'm the irrigation manager of bonds, but Amir is supporting these projects too. So Amir is handling seed processing, I'm handling this irrigation system. So I asked some help from him in some couple of slides, right? So what's the situation about this project? Can you go one ahead, Amir? You can see that it has a lot of steps for us to set up. So we want to explain today how you get that. But in a summary, in a nutshell, Iken Kano is in quotations. So we must send it for maybe more than 6 suppliers, so to get the best price. Ibadan is not initiated yet, but we initiate soon. Kumasi is in progress to pay. That means that in the next few months they will be on the ground. Tamale is designing the final concept, and we are explaining more about the process. And Ide in bulk, we didn't initiate yet, but I think we will soon, right? What will be the next one?
For example, Tamale, we have 2 sites. Okay, one site the design has already been done. Okay, the other site we are working on the design and the configuration. And for Senegal, we already started the discussions. We're getting the field data, and Vinicius will be covering how we're going through that process.
Yeah.
And afterwards, we'll start with Ivory Coast.
Cool. Thank you, Amir. Can you go one more? So we want to talk about the management of irrigation system. What is included, how we start the irrigation system, how we manage, how we maintain, and everything. So for the irrigation system, we have all these steps. We start the irrigation project, we define the infrastructure, we implement that, we operate, and we maintain. It's like kind of other operation, but has a lot of specifics in the irrigation system. So if I say for you now that we need to start the irrigation process, for where you start? Let's see the opinion. Huh? If I say I have a new irrigation system, what's the first thing that you do? How will you start? From where?
Okay.
What do you need to define?
For a new irrigation system, I think the first important thing is there should be someone in charge of the management of the system, because at our station, mostly everything depends on the scientists. So we have not centralized things, and the scientists might not have enough knowledge about how the system operates. So I think the first thing, there should be a manager of the facility who have knowledge of how the system operates. So the scientists will just put a request to the manager, then he delivers service to the breeding team.
How they request for you? They just say, I want irrigation there, or he requests some hectares. From where they start to get the demand for irrigation system?
Yes, like the current operation, every program has his or her corner doing his things.
Mm-hmm.
But as we have started centralizing, the best thing is there should be a farm operations, I think, as done in the CG. So you, the scientists, have to make a request of the land area. Mostly, if the whole area is under irrigation, that means the farm manager and the irrigation specialist, mostly is the farm manager who allocates the plot. So you make a request, maybe I need 1 hectare this minor season for this. So he will get it prepared and he will liaise with the irrigation specialist to ensure that the place is really irrigated.
Good. So we start to define where we put the irrigation system, right? And someone that will be responsible to manage the irrigation. Should you consider something more when you start the irrigation project? A part of the place and who will be leading that project? We need to see another thing to start the irrigation project, right? He said that we need someone to lead the project, right? And where will you put that? What more we need to consider when we start the irrigation project?
Let me give you what I saw or when drip irrigation was to be installed in Kano Station many years ago. It was a discussion at the top level by the bidders and the engineer in charge then, and who was given the mandate to come up with the technical drawings and many other things that have to do with the irrigation system. And after that, a team was sent to Kano to look at the portion that was best for the irrigation to be, installed. And after that, the parts were keep coming. I didn't know where the money came from, but all I knew is that it started importing the parts into the country, and I was among those who were there when it was being installed, and it came out beautifully. So below that level I'm talking about, those of us then at the lower level didn't know much or what really happened. But all we saw, but I think we're just unfolding gradually. But basically, I want to point out that before the installation of anything, they must have to be in place. There are stages you need to follow. One, where you want to establish the thing, and where the money is going to come from, and the type of irrigation you are talking about, and many other things that has to follow. Without that, you've not started. Thank you.
I think, I don't know if, okay, we'll take it that we've already sourced the funds.
Yes.
And now we want to install the irrigation system.
And he has a location too, and the project leader, right? What more we need to see?
Okay, yeah, I think the other things to consider will be the crops to be grown, because those would determine the kind of irrigation system that you need.
True.
And then also you need to look at the topography or the terrain, the landscape where you want to install the irrigation system. And then also the other things that you need to consider, the sources of water. What kind of, are you using the boreholes or it's a dam? Because some irrigation systems require lots and lots of water. And then, of course, you need to look, do you have the expertise to maintain the system over a longer period of time, to sustain it, in short? I think maybe my colleagues will add from here.
Yeah, okay. I also wanted to add that, you see, as Dr. Webese said, you have already gotten a specialist in place, you have set up the system. I was thinking then there should also be an SOP, there should be a standard operating procedure, such that when do I request for it? Who do I go to? I think that one too is important so that there will not be chaos. Yeah.
For sure. And all the points that you bring here, we'll talk today. Danny, you want to?
Oh, okay. I think most of the things have been said, but probably I'll put it into 5 categories. Probably the first one is obviously the capital. For you to start a project, you have to have enough muscle to make sure that you can fund it. And then the second one is the personnel, be it the coordinating team that is arranging or doing the logistics in terms of what is required, and also the operators for the system. You can't put up an irrigation system where you don't even have any trained operators for the system. And then you look at the infrastructure. What is there in terms of infrastructure? We're looking at the soil, someone has talked about the topology, the water source, and also even the equipment. What do you want? Is it going to be drip? Is it going to be overhead? Is it going to be these big center pivots? And then the purpose, is it an open field, or you're going to be doing greenhouse or any other? And then obviously the most important one, maintenance and sustenance. This has to be looked into as you set up your irrigation.
Perfect. We can see that's very complex, right? Go ahead, Gabriel.
Yeah, I think you actually captured most of the things I wanted to say, but I'll be talking from a technical view. In irrigation system, like if you have your funds and you have a site selection, I think what really comes to play now is your design and your material selection. If your design is wrong, no matter how the expertise are, they will never get it right. Because your design is like the foundation of the system. So once the design is wrong, then you keep on manipulating and you never get it right. So no amount of SOP you are bringing in, you can never get it right. And another thing that matters again is your material selection. If you use inferior material, there won't be sustainability. So that's it. Thanks.
That's true.
Yes, to add to the design, I think one important thing is also the economics in terms of the usage of the facility. Because from one experience we had, and Ame was there, the One Bomb project, it was designed in such a way that you have to pump water from the main dam to a reservoir. And you also have to lift water from the reservoir to the main field. So, and it becomes very expensive to utilize the system, because if you are buying fuel, that means you have to buy twice, because you have to lift water from the main dam to the reservoir and also from the reservoir to the field. So you also have to, and it became very expensive, because if you are a breeding program, you are going to use the place, you have to provide for the fuel. So even though the system will be there, because it's not economically feasible, you cannot use it. So you also have to look at the economics of the usage of the system.
Exactly, yeah.
Information. The Wambong River is 22 kilometers away from where they have their research site. So they're pumping all the way, okay, to provide water to that station, which is a very long distance.
Yeah. It's very complex, right? And it still have points that nobody mentioned. So I'm gonna go one more slide. So what I try to say here is irrigation system is really complex and has a lot of ways to do in the right way. So when you come to analyze and to make some irrigation system, we have a lot of different opinions, and that works. What we need to fit it is on the budget and the knowledge and what we have in the market. So when we start, we need to start from all the points that you say as well. We need to see the weather data, right? For the past 5 years, how much you need to put from water. What's the period that you irrigate that? One to use for drop screen trials, one to just for maintenance, one to for the nurseries, one for seed multiplication. So what's the goal? We need to see the water data first, right? We mentioned the crop season, right? The crop system as well. We need to see the soil type, because this is influencing how much the water stays in the ground. And as well, we need to see another biotic stress and the socioeconomic things in the area. So I give you an example from Uganda. We have a problem because the people go there and installing all the pumps. So we need to analyze as well. We need to fence that place. We need to use another kind of material that the people around is not interested to that. So like in Kenya, we cannot use steel in any part, because everything that's metal, they go collect to sell. So just plastic. So the economic part, the social economic part is important too. You need to consider that. Huh? Go one more, Amir. So we see how to start. We see the crops, we see the location, and we see the environment that we are on. And you go for more the technical specification to start the infrastructure. One more, Amir. So we start to say something, right? So just say about the topography, we need to analyze the crop type, the water source, the water requirements, the location, as Amir told, like some water location is very far from from the field that you want to irrigate. As well, we need to see the evapotranspiration of the crops and the soil, right? And what you have in the market, right? Sometimes some vendors comes from outside and say this is the best, but when you need to maintain, there is not availability in the market. So all of that we need to consider to do the irrigation project. One more, Amir. So in the end, this is supposed to be the summary, the technical drawers. Here we bring 3 examples. Maybe Amir can help me with this because he was dealing with that, right? What we want to say here, maybe Amir can bring like a different quotation from the same project that you have, and how was that, how was the difference, and the details about different kind of projects.
Right.
Different quotation about the same project.
For example, in this example here is something that we actually deliberated a lot on before we got to the final design. And this is in, this is in Kano, right? Yeah. So this site is in Kano, okay, and this has been split over 2 different systems. We have 2 different systems there in that design. So we have 2 requirements that we need to calculate. Okay, so we have the overhead system, and after the overhead system, we also have the sprinkler system. So we have to accommodate 2 different irrigation types. And for those 2 different irrigation types, we have different calculations. We have allocated a pump for each, okay? We have allocated the main lines for each, okay? And we had to also accommodate the amount of water that we need for us to conduct our operations per day. And after that, we calculated what is the requirement that we need for to have for this reservoir to have an ample amount of water for us to survive operations for at least 3 to 4 days on the station. It's not every single day that we can pump water to fill our reservoir. Sometimes the water is not available. Sometimes there is scarcity. I know that for example, in Lusaka, you mentioned, Vinicius, that they have a problem with water availability in their boreholes. Okay, so they will not be able to irrigate their fields, okay, because of the lack of water. And this is something, and we actually have been in discussions regarding the boreholes, I believe at Ikene, okay, to see if we can accommodate the irrigation requirements that we have for the designs, okay? And we're still waiting on that result. It takes a bit of time, okay? We need people to come in and check the underground water levels, but this is a necessity for us to be able to make sure that we can sustain these operations with our current design and our current field requirements. Another example here is this site, for example, the small design is at Nyampala. Okay, this is the site for Sari, for example, okay, where they have the research. They have a combination of drip and sprinkler irrigation. Okay, and we have accommodated the design based on that, and we have deliberated on this repeatedly to make sure that we capture the requirement correctly, and we make sure that our calculations fit the requirement, not only for the breeders, okay, but also for the operators, okay. Things have to be sustainable. Things have to be manageable at the same time. We cannot go through highly sophisticated things while we are unable to sustain them. Okay, so we have to make things manageable. The one below is the site in Kumasi, and this is just one block, okay, of land there. This is one of they have 4 different sites at Fumeswa that require irrigation. Okay, this is only one of those sites. Okay, we're taking this for a complete change, complete setup, and going through different vendors, we will find different solutions. We will find even at cost, okay, some cost provided a quotation about let's say 600,000. others provided quotations about 350,000. We have to evaluate the technical components of every single item, every single pipe, every single dripper or emitter, for us to be able to make sure that whatever we are providing at any site is something that is secure and sustainable for a long period of time. We cannot stress enough the matter of sustainability.
Amir, you bring you one example that the same project has a quotation of 300 and 600, right? Is the double. Both suppliers can deliver the same result in the field. They can deliver the irrigation that we need, that we're expecting. And what's the main difference between the price? What's changed?
Okay, sometimes it is a matter of quality. At other times, it's a matter also for the providing companies, because eventually they are providing services as well. Yes, so they have to install, etc. They might have a high margin, for example. Okay, and this is possible in the market. Maybe there are different sets of qualities of products in the market. So we can have low quality, good quality, and we can have the cutting edge or top of the line. Okay, sometimes we can work with the good quality. It will provide us with everything we need, okay, if we maintain it properly. If we go to top of the line, it is not most probably, it is definitely very expensive, okay? Again, there are many variations in the field. There are many companies, even highly reputable companies, okay, with competitive prices, but we have to always compare the technical aspects of each component before we give the okay on this. For example, for Kumasi, it took us about a month and a half after we received the quotations, just deliberating on every single detail from every vendor that provided us with the quotations. We had to go that deep, okay, for us to make sure that at least one, from our part, we did the right decision. From another part is that we can make sure that once this is implemented, that it is sustainable and it will provide the results that we need.
So basically, what I want to try to say for you guys, we are here to help, okay? Excellence in Breeding can help to analyze the projects, to see the quotations. And we are asking you, don't go to the vendor, say, I have this area, I need the irrigation. Because you can see how much details you have, right? And how much things we need to analyze. So once that you have a project, we are here to help. We have external consulting as well. That's Chakib, that stay in New York and has a huge experience in the projects. Me and Amir and Gustavo as well can help with the technical details. So I want to open the mind of you that is really difficult to do irrigation project, and it's really we are here to help you to analyze and to get the best project for you. I think Gustavo has some comments.
So Vinicius, can you hear me?
Yes.
Okay. So so you mentioned that, well, one thing that I learned in this research stations is not only CGI, but all the research stations, that the way that they work basically is the same. So, I have a demand for the irrigation. I need to irrigate this area and go to the vendor and ask quotation and okay, so and then submit for the project, approval, etc. So go for this is my area, approve. So this is general. And irrigation system needs to be also infrastructure plan for the station, because it's a long-term investment. Most of this investment is should be at least or more than 10 years, definitely. And if it's not really or thinking, if you're not thinking like that, you always have problems. And hey, now it's not working and you don't know the reason, and then goes to different pressure, etc. So it's a mix of things that prevent you to effectively deliver the water that is needed. Anyway, yeah, so just thinking beyond, as you said, beyond, hey, let's install something here. I need a drip. I need a drip here. No. Think as a long-term infrastructure for the station.
Thanks, Gustavo. By the way, just a small correction here. This design is for Ikene. We have a similar design for Kano. Okay.
This is Ikene station.
Yeah, this is Ikene station.
But anyway, I just want to bring some examples and to see how many blocks you can have and how many arrangements we can have in the technical drawers. And we are always facing this in two points. One is easy to operate and to maintain and to decrease the cost. Let's go ahead, Amir. So we need to implement after we see the project, right? Go one more. So we discussed about the requirements, what we need to see it, right? And the technical drawers and how we can do it. So once that we implement, we need to check if the technical drawer is correct, right? If the block distribution is accommodate the operation and the breeding trials as well. And if you have the correct irrigation type, the irrigation filtration, pumps, and the water source. We'll go detailed for each point of this, but before, Amir.
Yeah, sorry, you want to go into details before?
No, go ahead.
Yeah, because you mentioned the first thing, getting the correct technical drawing. One of the challenges that we have been facing, and we're going to start crying our eyes out, okay, is that we do not have a good on-site map. Okay, the stations that we are working with, we're relying on GPS maps, or sometimes we're going to the fields with our GPS, okay, to be able to map and to be able to plot the fields on the map, so that the design needs accuracy. Okay, we are calculating certain contingencies, okay, for the design. However, this is not something that is highly sustainable. So on the long run, okay, this is one thing that we need to work on for all of our stations, is to have the blueprints for the fields, the design for the fields there in accessible soft copy format for future reference, for any reconfiguration or any even projects, complex projects such as irrigation that we need to do.
Good, Amir. I think one thing that we saw here, we need to see the topography of the terrain, right? This will change how quantity of pipes and the kind of pump that you need to use and everything, right? When you go to the stations, normally they don't have the survey of the area. They don't have the topography, and this can change a lot. So we use the Google Earth usually, right? Or a hand GPS. And this has a mistake of more between 5 and 15 meters from the point that you're getting. So this kind of measurement that's not so precise, when you put to implement the project on the field, makes some difference. And you need to fix directly when you are implement that. So to have the topography of the research stations is really useful, not just for irrigation, but for planning and for everything. I think you should go in there, but it's quite expensive to do that. So just have this in the radar. Maybe if you have opportunity, it's really useful and really helpful. Go on more, Amir. So you told how to initiate the irrigation project and how to operate. How you use to operate the irrigation project? How you know that when you start to irrigate, when you start to stop the irrigation? What kind of parameters you use to that? Go ahead, Gabriel. I don't have the mic. Yeah.
Okay. Yeah. Thanks for these slides. For irrigation operations, there are like a lot involved in it.
Mm-hmm.
You have to actually understand the terrain of land.
Mm-hmm.
You have to understand what's it called, your drainage pattern. You have to understand the crop water requirements of each crop, so that you won't over irrigate or under irrigate, because all of this will actually boil down to your scheduling.
Mm-hmm.
If you don't get a proper scheduling, then either you under irrigate or over irrigate. And another thing that that really matters now is your weather data. If you irrigate in the afternoon, obviously there will be a lot of evaporation going on. So the time at which the timing of your irrigation too is very, very important when it comes to operation. Then another thing I want to add now is most people go into automation just because they want all their parameters to be precise. Now we are doing breeding. We are not irrigating for commercial purposes. We are doing irrigation for breeding. So there must be like a total planning between the breeders and the operation teams to know the type of design they have on their plot, then to know the type of operation that best suit that design, then to know if we can go manual or automation for them to get precise results. Because what they want, let's say for example, they want 1 liter of water per crop stand. We have to give them 1 liter of water per crop stand, not less, not more. Then how can we achieve that? In my own opinion, I think is automation that can actually give us that. Then what does automation entail? We have probably sensors. We have moisture probes that can tell us, okay, the level of moisture content in this particular soil is reduced. Then you have like a trigger that can trigger a system, okay, release water. Then the timing of irrigation too is key. Thank you.
Good. Go ahead, Teresa.
Yeah, thank you very much, Gabriel, for everything you have just said. When you were saying it, as if we already have that system in place. Okay, you're just stating the ideal. Okay, so I think those are the things that actually needs to be improved on. It's usually challenging sometimes when you request for irrigation on your field and you get there and find out that only one part of the field is irrigated, the other part is out of irrigation and the water is off for the day. As a matter of fact, they've removed all the pipes and have taken it to another field. So this is actually challenging for now. So he has said the ideal situation that we love to see. So, but I don't know where we are going to start from, especially the water requirement for crops. Where are we going to find this information? Do we have it somewhere, or we have to go back to the, past research findings?
Yeah, there are some standard crop water requirements for some crops, especially for, let's say, maize and some other grains, based on research and literatures. But there are some crops that are very complex, like banana and plantain. I'm not sure there's an adequate crop water requirement for those. So in that sense, it's just to work with the breeder. The breeder that is working on the project probably does not want the banana or plantain to die, for example. So in that note, there won't be any specific crop water requirement. You just have to know, okay, we need so liter to survive. That doesn't mean that's specific, but that's what the breeder wants you to do. So, and in that sense, we have to be precise as possible.
I agree, but partially disagree. Okay, there are certain standards there, but you also have to calculate your evapotranspiration. So there's the evapotranspiration from the weather. So you have the weather data, you have the soil type, you have the root depth, and you have to calculate the evapotranspiration for the crop. Okay, so based on that and based on your location and weather data, you can calculate the water requirement. It has to be site specific. Okay, you cannot rely on standards, okay, or what has been done in literature. You have to look at the weather trends, okay, before you can move forward, you know?
So Teresa, do you find difficult to find this kind of data? Like what's the water requirement for your crop or for your trial? Like you don't have literature to looking for, or you think that's missing some training for that? Is the breeders have some difficult to get this data to give to operation? What do you think?
For yarn, generally, we normally look at the amount of rainfall in the predominant area of cultivation of that crop. So I think that may give us the idea of what amount of water should be available for that crop within the growth season.
But do you know how to determine, like, if do you do like drought screening trials, or you just want to irrigate to keep the crop well? Yeah,
of course. We do droughts.
Drought screening.
Yes.
So when you do the drought screening trials,
maybe not here in Ibadan. It can be elsewhere, maybe like in the north. We've done it in the past, but currently we don't have that research going on.
I see.
Yeah, for cassava, because of there's actually a bit of complexity when you think about what the water requirement is. For example, cassava grows all over Nigeria, from the very northern Guinea savanna that's very dry to the high rainforest zone in One. But in all those areas, it survives and then does well, depending on your fertility and co. However, what we do in places where we need irrigation, that is why if you're on the feed yesterday, you hear Dr. Rabi saying that we only take advantage of what is happening here in the dry season to enable us get the crop to be established. And once you get up to 3 months after establishment, you can leave it without water. So that is what we do. I'm not certain if we have really worked to get the water requirement for. I do not think that one is necessary for cassava anyway, because of the nature of the crop. What we have always done is just to say, we are in the dry season, we want the water irrigated, and then we say, okay, if you have 2 hours of irrigation in a day, and you irrigate about 2 times in a week, that will sustain it throughout the period of growth. So that is what we have been doing. Maybe we have to look at specificity, but as it stands today, we've not been looking at that. Thank you.
So Gifty has some comment in there over there. Can you give the mic to Gifty?
Oh, thank you. I'm thinking if we were to look at the current irrigation systems that we have, I will not speak much about here because I haven't been around here much, but if I look at ours in Zambia, or maybe even the one I saw yesterday, the sprinklers, I'm thinking that it is more of a blanket application where we just apply water and maybe say, we estimate to say this amount of water that we're irrigating is enough. Because for us to be precise in irrigation, we actually need to know all those, the crop requirement, the water losses, and then from that, the evapotranspiration, all those losses and what is needed, then the difference that is when we can find exactly what it is, the amount of water that can be applied. For example, if you look at our soybean trials in Zambia, you have one big field, let's say 5 hectares. Within those hectares, within those plots, you have early, medium, and late. And then you are using one irrigation system that is not really calibrated to say when it reaches here, this one is early maturing, we need to apply this amount of water here. We just apply the same for all the plots. Yeah, so I'm thinking maybe for us to move from that kind of operation, we need to have a weather station where we can also measure the evapotranspiration. And also maybe if we are given the specific water requirements for each crop, that would be easier to irrigate. And also we design the irrigation systems in such a way that we are able to apply just the amount of water that's needed, unlike what's happening now.
Gifty was a pivot, a lateral pivot. So that's why he's saying, because the pivot's moving, right? So has different plots and different kind of specific irrigation demand. So the pivot just apply blankets, you know? I have a question for you, Gift. So in the end, they say for you, you need to irrigate from 7 to 11, right? Some amount of time. From where this number come from? Who says for you, you need to irrigate 4 hours per day or whatever? Like someone knows where this number come from. I think you're doing because from the past you are doing. From the experience is a good point to start. You know? Yeah. You go to observe the crop is a good point to start, of course.
Yes. I think the number of hours, the scientists just tell us to say you need to irrigate our fields. We need these fields to be irrigated and like that. Then, just from experience, or just either increase or reduce the speed of the pivot so that maybe to move a distance of 100 meters, it's going to take about, like our pivot, for example, if it starts irrigating at 7 and we set the speed at 20, it's going to take about 4 to 5 hours. That 4 to 5 hours in our minds is enough to give us maybe 10, 15 millimeters of water a day, just from estimation. We are not precise.
Okay.
Yes. Calibrating the pivot or
Thanks.
Well, the pivot has nozzles eventually that are providing the water or sprinkling water. So have you calibrated those sprinklers anytime during the operations?
no, the nozzles are not calibrated, but what usually determines the amount of moisture that the pivot to irrigate is the speed. So what we usually calibrate is the speed.
But how do you know what you're actually providing, on the soil, if things are uniform or not, if you do not calibrate?
All the nozzles on the pivot, because every 50 meters has about 24 nozzles. So all of them for the 350 length, they are calibrated to give out water at the same rate. All of them are uniform. What just matters now is the speed. That I'm not sure I'm explaining.
Well, okay. I guess we'll cover that later.
Let's make it better understand. So I understand you, Gifted, that you're saying that all the nozzles is the same, right? And give the same amount of water. What changes the speed? If they go faster, they reduce the quantity of water, right? If they go slow, they increase the quantity of water. And this is correct, huh? This is supposed to calibrate just the speed in the pivot. What Amir is saying, if you are checking if your nozzles is doing what they're supposed to do to give the same amount of water. So we need some procedures, right? That's a piece under procedures to check if all your nozzle is doing the correct thing. If some nozzle is not calibrate, maybe get damaged, maybe it's not clean enough or something like that. So the concept to calibrate the amount of water is correct. And the concept to maintain the amount of water is correct too. So we have two things. One is to calibrate the amount. Another one, you check if the calculations that you did is good. But I think, I don't know in this part of Africa, but there, just in Lusaka that I see the pivot. The other is just a sprinkler and drips. And this is a little bit easier for us to
they have the lateral
calibrate.
systems.
They have. That's good.
And it's in the designs that we have worked on. So
I like the system, not for drop screen trials, but for other kind of breeding trials is okay. Let's go one more slide. So everything you can go click 3 times, please.
We have a comment from Gustavo.
Okay.
Yeah, Vinicius, I think that you started a good discussion, and probably this team will need to talk more about how to define the irrigation demand, because clearly, and this is definitely an area that we need to improve, and the impact and the result for that, it will be tremendous if we really improve that. The way that we calculate, the way that we define the irrigation demand. There are crops that for instance, if you irrigate 80% of the field capacity, it's the maximum productivity. Meaning that if we are irrigating without knowing these parameters, we may be irrigating 100% of the field capacity to 100% of field capacity, and the crop will never achieve their potential. And for a breeding purpose, we are doing completely wrong. We should select based on the maximum potential. And anyway, I'm just saying that we need to spend more time and more effort trying to target this aspect, or how to define demand, rather than going to the maintenance of the irrigation. Of course, maintenance is important, but if we don't know what, why, and how, or how much we need to irrigate, it is useless. Anyway, yeah. So just a comment. Yeah, thanks.
Thank you, Gustavo. Just say for him to do that. Thank you, Gustavo. So you just briefly explain. I think so. Maybe we should provide some training or maybe some bond webinars to talk in details about this, how to make the calculation. Can you click? Come here, please. More. So we are saying about stressing time, okay? So when I start, when I stop, and when I do the last irrigation. So this is the point here. When I do how I do that, how I achieve that, right? And like here, the stress intensity, for example, this is for maize. This is an example from CIMIT. They told that we're supposed to stress between 40 and 50% until 30% for our drop screening trial. So they have the numbers, you know. So how to achieve that? Can you go forward? Yeah, about the soil moisture profile, okay? So anybody recognize that? Anybody has this for the crop, any crop? I don't think so, right? Just to remember, right, from the university, so we have like the field capacity, the wind point, and the saturation, right? The saturation when they start, the water start to put out everything out, right? The fertilizer, the soil. The field capacity is the maximum capacity that the soil can absorb water, can retain water for the plants. And the wet point, the water is here, but it's not available for the plants. It's connected to the soil particles, right? So you have these 2 points, actually 3 points, right, that you need to consider. Saturation is after the field capacity. So actually you just determine the field capacity in the wet point. And this is change, yeah? The moisture content inside the soil, you change. So here is a soil profile, right? And this is the moisture content in the depth. So we see the superficial is a little bit less, and then you go for 30 centimeters is more, and then it's going decreasing. So to understand how your water is inside the soil is very important for us. Where your roots is going. If you go so deep, maybe you need to consider here and not there. So to understand the soil profile, moisture is really important for us. So this is a point of start. And this is determined by how the particles in the soil is changed. So that's why we need to analyze the soil. Is a clay soil, is a sand soil, is a loam soil. So we need to determine this. Can you go one more, Amir? In the end, we have the water retention curve, right? What that means, you determine the wilt point and the field capacity, and you play between these two. If you go lower than wilt point for the moisture content, that means your plant will die because there's no water availability for them. If you go to the field capacity, is the maximum capacity that the soil can retain water. We need to play always in the field capacity? No, depends of your crop. As example for Gustavo, some crops has 8% of the field capacity is the maximum productive for that. So in this case, we should irrigate until 8%. If you want the best yield for your crops. If you want to drop screening trials, you need to play with the stress, hydric stress in your crops. So you need to determine these 2 points so you can play with this margin, you know? So this is where the how many hours irrigate come from. When you do, you have 2 ways to do, huh? If you don't have the soil probes to see constantly how much moisture you have in the soil to control this variation that you want, you need to use the evapotranspiration. How much the water goes away from the soil and away from your plants. So you need to use a weather station for that. So you calculate for evapotranspiration. It's a good way to do. It's not the really precise one. The precise one is supposed for you to control the moisture content of the soil. Well, one more, Amir. Oh, sorry, just come back one. And sometimes you need to play how many % of the stress you need depends of your stage of your crop. So for example, here is a fruit tree. So in the fruit growing, they stay lower. And then when you go to harvest, they increase the amount of water. So this is you change your crops as well. So all the breeders supposed to give you this protocol. How many % of the field capacity they want that you irrigate that crop. And then the operation side can control that. Or maybe they can say, I cannot control because I don't have the tool. So you have the agreements to do that. Go on more, Amir. And this change with the rainfall is another thing that will change your moisture content of the soil. So this is on the time, right? It's 50 days and all the rain. I think we should go deeply onto that, but we don't have time now. So let's make a training. I think is a next step for us, Amir. From the bond to give in details. The important message that I want to left here is to control the irrigation. You have two types: evapotranspiration control, or you control the soil moisture in the soil. For the evapotranspiration, you need the weather station, and to control the moisture content of the soil, you need the soil probes. So, excellence in breeding. One more, Amir. Excellence in breeding is bringing inside the packet of equipment the soil probes and the weather station, okay, to help you to control the irrigation, and we will train you how to use that. So this is an example of soil probes. Most probably this will be the one that we'll send for you guys. This is a Bluetooth. So basically it's looks like a pipe, right? You put inside the soil and they have sensors along all the way down. So they have it between 10 or 20 centimeters each. And they give you the soil moisture content in your profile. The size of the probes change from 60 to 1 meter and 20 centimeters. So this will depend how much your roots goes and which crop you are talking about, right? The important point here in the soil probe is the allocation of the soil probe. So when you have a trial, the breeding is supposed for you to say what they want to measure, right? If you put beside the drip line, you have the moisture content in the drip lines. If you put between the drip lines, you'll be another soil moisture content. So it's important how to place that and how much is representative that region for all your trials. Don't worry, we will bring training for you how to place that. The important thing, we have solution and it's easy, you know. So all this is Bluetooth connection, and you just go around the soil probe, and this thing is connected with your laptop, with your cell phone, and everything. So they bring the data ready for you. You don't need to make any calculations. You just need to check if your irrigation is putting the soil moisture that the breeders ask you to put it. Another thing that you are bringing is the weather station, is autonomous weather station as well. You don't need to do anything. You just need to check the data. The important thing is to use that. What we can see in some stations, we have the weather station. The data is available, but we are not using. So we have the information and you can do better, but we are doing by time the irrigation, and you can use the evapotranspiration. So it's important for us to bring the equipment, but more important is to make the application of that. I don't know this side of Africa, so I would like to ask if someone is using any kind of weather data for irrigation, or the breeders using the weather data in the trial analysis. You see someone using this kind of data. Are you using? For what? Like, can you give the mic for her, please? Thanks, Amir.
Yes, we have a weather station that we use for basically for pollination activities, trying to find the optimum time of the day, the temperature, the moisture in the air, the humidity and all of that, and how that affects the success of.
So you correlate the best time of pollination when to do more seeds, right?
Yes.
For the weather conditions.
Yes.
Good. And how about yield? You see like this year my yield is better because we have more rainfall or something. How is
We
that?
are yet to evaluate that, but we'll still work on that.
What's your difficult to do that? Like the weather station data is connected with the EBS system or something? Are you using EBS system?
No, we use a memory card to download just to log all the data.
But this is connected with your breeder system,
yes.
Or no? It is?
No, to personal system. I take the data out and give it to the breeder.
Okay, good. Our intention is to connect with the breeding system. So once that you analyze any kind of yield or anything in your trials, the weather data will be connected. So like you can check it out. Okay, I have more yield here, but the rainfall here is better, or the humidity is higher, or the temperature is low. Something like this to be easy. Amir makes some I cannot see the
part of the survey that we had for today. For example, at our station, we link weather data to irrigation scheduling. Okay, from the 8 responders, okay, 6 mentioned that no, it is not true. We do not do that. Okay, and others said that it is a little true. Now, would be nice to see how the ones who said yes, would be interesting to see how they are actually using that. For the using it for yield, for yield, okay, 2 said not true. The rest were true. Okay, linking weather data to pest and disease monitoring, majority said that it was not true. Okay, so that's the higher number. Yeah, that's it.
So good. We have some numbers to show us that we cannot just bring equipment as weather stations or probes, and we don't teach how to use it.
Vin, maybe, and also Amir, maybe you can help. You know, from experience, there are also commercial farmers. You know, they do what they call mapping. As they harvest with a combined harvest, they can easily pick portions of the field which are doing well and those which are depressed. Can we also link this to our irrigation as well? To say, you know, as we go through the harvest or as we do our operations, mostly it's yield anyway, which determines the fields that are depressed. Can that be linked also to the irrigation system?
We can link that. The problem is when you set up an irrigation system, it's really difficult to make customize for each area. So like I have a sprinkler, right? I cannot say for the sprinkler, okay, you reduce just here and there's overlapping. The drip is just one drip tape, right? So it's a little bit difficult for us to customize per region if the block is too small. So the first thing, we need to determine the size of the block, and then you can try to customize that. With the pivot, is a little bit easier, but as well, we have the minimal plots that you can do it.
Before Gustavo, just the parameters that we have for successful irrigation in the field is not limited to the irrigation equipment. It is also the way the field is prepared, okay, and the parameters in the field, the variations in the field. What you mentioned, basically, that what we can analyze is the variations in the field, and we see how we can remedy, okay? Maybe there could be, it might be not leveled, or there might be other issues that we need to attend to. But to have variable rate irrigation systems, that would mean we need millions and millions of dollars. Gustavo?
I did calibration problem too, Lenny.
So I didn't understand well the Lenny's question. If you were talking about variable rate for...
Well, 1 second, Gustavo, we can't hear you, just a second. Okay, we can hear you now.
Can you hear me now? Yeah, great.
Yes.
I didn't understand well your question, Lenny. You're talking about variable rate for irrigation, is what you said?
Not necessarily, but what I was referring to is, Gustav, mostly I've had the experience in South Africa, parts of Zim and Zambia. As the commercial farmers harvest, and some even on our research station, there was also an element of mapping the field in terms of yield. So probably let's say it's a hectare of maize or a hectare of soybean. You could easily see that everything was constant in terms of resources, the fertilizer, irrigation. But portions of the field are not responding well to all these. Probably, you know, there's a corner which is getting less than half of the rest of the field. So probably then they would focus on correcting that area in terms of irrigation, in terms of fertility, in terms of even soil preparation and all these other things. But most of it would boil down sometimes to probably there's a gradient. Any water that is running off is running off with the nutrients and amongst other things. So that's the question that I was referring to, say, as we set up this system, is it possible also to map these permanent blocks relative to irrigation? And Amir also said, there's no reason to focus it on irrigation only. It will be cascade down to all even land preparation amongst other things, and even nutrient application.
Yeah. So now I understood your question and what Amir said, and so this goes to the that's also the station plan. We need to design the minimum block or the field, the size of the fields, and that field needs to be always managed as entire field. Because if we, just as an example, we have one, and we discussed that with when we did the one irrigation system for Melkasa in Ethiopia. We started doing that, and no, our field need to have 1.5 hectares each field. Okay, so then we start discussing, no, but sometimes we have 1.5, but most of the time our field is 0.5. Okay, so we need to have 0.5 fields. And this is the minimum area that need to be managed, or we need to have irrigation valves to manage that 0.5 hectares. Otherwise, you will have always activities in part of the fields that may create some variation, as you said. So you apply, and you always need to correct parts and create this challenge. Of course, you need to have data to track data to record this data to analyze that in the future. Okay.
Thanks, Gustavo.
But definitely, this is an area that we need to improve to record the data and goes to the farm management system too. Sorry, Felice.
Yeah, no, thanks, Gustavo. What you're saying here is precision agriculture, right? We are a little bit far from that. And when you go for really small plots as the breeding trials, it's really hard to do that because you're right treating your plot very small, right? Sometimes it's 2 lines, sometimes it's 1 line. So change much from one line to another. And the precision agriculture uses a system that try to recognize the standard in outdoor trials. So when you are changing line by line, they make me really confused. I think once in the future you'll be there, but you're not in that stage. And we need to treat really different from the breeders. Maybe for nurseries or seed multiplication is okay, we can do that, but for the breeding trials, no. Can you go ahead, Amir? Thank you. We didn't talk about the stress uniformity as well, direct to the point, but it's what Eleni was saying. We went to the field yesterday, right? So we can see like the sprinkler was in different parts, right? It was not straight. Some sprinklers was bending, some sprinkler was lower than the others. So all this is about uniformity, right? If you don't have a good uniformity in your trials, you can manage your time really well, but you increase more heterogeneity in the field. So it's not just about the timing that is connected to the moisture content of the soil or the evapotranspiration, but as well as the spacing. We need to calibrate our irrigation system. We need to calibrate the sprinklers, you need to check the drip lines and everything. Can you go one more? So I want to bring here a good example how to help to make all these checks, how to help to operate the system. So this is really visual things, right? You have the tasks, the daily tasks, what your operator must do it. It's simple things, but it's really, really important. And it's there in your pump house, you know. Some they as well, they put like the photos and how to operate all the machines there. Really useful as well. How is your system? Which pipe you connect with each field? So most of the time when you go to the stations here, you say, okay, I want to irrigate this and that block. How I do it? I need to call someone because he's the only one that knows about it. And this is really bad for us because if this person leave or is in vacation, nobody will handle it well. So this is a good and easy solution for us to do it. Make a visual. What the guy need to do every day, how to open each block, how to operate that, and how is the safety rules that they need to apply. So I think this is a good thing for us to implement in other stations. Maybe we can discuss this in the city process as well in the field trip that will be in the afternoon, right? About the maintenance. So we talk about operation, right? The time of operation and how to make more visual and easy for them to operate and how to maintain that. Can you one more? So I will not read everything because we are run out at the time. I will left you this summary for you guys. Is Amir is put in the Dropbox. So it's a summary about the difference between the main components in our irrigation system. So here, for example, is the difference between the main types of drips and how to use it. What's the advantage and advantage, okay? So the pressure compensating drip lines, you're using a flat area. No, this is supposed to use in a slope area. So here's the advantage and disadvantage and how you need to manage it. So I will ask you guys to have a look this after our sessions. We have for drip, go one more, Amir. We have for the sprinkler as well, okay? We have for the pumps. Sorry, for the filters. I think Amir filters, I want to stay a bit here because it's really important. Please. So when you go to the
can I say something here? We've all been to the banana plot yesterday, okay? And one of the things that we commented on was the actual availability of sprinklers while they are using drip irrigation at the same time. So the reply was that they are using the sprinklers as backup because they are not sure if the sprinklers are going to provide, if the drippers are going to provide the amount of water needed. So this goes into the design, the technical know-how. I mean, to me as an operational person, okay, this is absurd. Okay, so you either have calculated what you need or you have installed the right system for your crop or you have not. To have it as a backup, that means we're trying things or working in things by trial and error. And this is not acceptable. I mean, we're all of the new age, okay? So we need to actually implement the science to actual practical use.
Amir, like I go to the field right now and then I have a drip line that I'm not sure if you're delivering the amount of water that you're supposed to do. Maybe in the end of the drip lines, I'm guessing that's not so good. How is it the easy way for you to check? My drip line is delivering the amount of water, or is the same amount of water in the beginning and the end? How I can check? Very simple in the field to check if it has difference.
Well, it can show from the crop, but I can also calibrate. It doesn't take much time. Just put some cups, collect the drippers by 1 minute, okay, and you can get your result there. You can visually see it also if there is a difference or if there is a variation. If you want to be detailed, you can have a weigh balance with you in the field and you can weigh how much water, okay, is available and calculate the volume.
But we need to simplify, right? If you see the crop, I'm sure someone say, no, it's different clone, it's different different crop, maybe, whatever, right? Go there and put some some cup and collect the water. You can easily see it. If it has different, you know that you need to fix something, right? Yeah, can you pass the mic?
Thank you. I wasn't with you on the field when the person in Banana gave you that answer yesterday. But from what I know about what happened on that field, the farm manager is here. He was actually deeply involved. They were thinking of changing from sprinkler irrigation to drip system. Then they started the drip system. It has not worked what they expected to do. It's a matter of coming out to say, this is the challenge we are having. We need this to be installed to see how it works. I don't know whether you were there when I was telling them on the cassava field, the challenge we're having with the drip system of irrigation within our EiB-IITA. We've tried a lot of different things. We've even tried to automate a system of drip that take into consideration the depth of percolation you have with water, and then it also gives you a kind of feedback to you too. It gives instruction to the you use artificial intelligence, telling it it's time for you to irrigate, time for you not to irrigate, and what you've gone through. But I will say maybe because I'm not too sure. Maybe because we have not got the right technical people, or we have not got the right equipment, or we have not got maybe one or two things, I don't know. But that has been a challenge with the drip system we are using on right on campus here. Like I said yesterday, if things work out the way the breeders expect, then nothing wrong in changing. But for what we are seeing on the drip irrigation system right now on campus is giving us a lot of nightmares. That is the truth.
So we come back right in the beginning, right? We need to define the field capacity, the willing point, how much you need for that. Once that you have this number, I know how much water I need. So if I know how much water I need, I know the drip line that I need, or the sprinkler, how much water I need to put. So you come back to the beginning, right? First, you determine the number and not guessing. Okay, you turn on 1 hour, the crop is feeling not so well, so I put 2 hours. No, it's not like this that's supposed to do. You're supposed to determine the willing point, the field capacity, and how much your crop you need.
As expected. It's not dispensed as expected. So I think the whole system has a challenge that needs to be addressed. Otherwise, those fields before today, before this period, the sprinkler irrigation there have been working very fine. And even tonight, still working very, very fine. It's a case of we want to change to drip. That is what brought up those systems that are there.
So maybe you can get the amount of water that the sprinkler was applying before and try to put in the drip. Remember, the drip is more efficient, right? So we need to compensate that. But this is a start point. If you don't have like the willing point and the field capacity, that is the correct procedure.
Sir, I think Mr. Wilson has to say something.
Yes, he was in Israel and he was taught irrigation. The people who did that drip irrigation messed it up.
Okay.
That's just the truth. Because if you check the point of the drips, it's not tallying with the crops.
Oh.
Look at it. No, simple observation. Apart from the technical calculation.
Yes.
So, Mr. Wilson has a lot to tell us. And I was still expecting that after that, your training, sir, you were going to send us your training papers when you came back from Israel on that course. And then you need to see, we need to be open so that we can get help.
Yes.
People believe I talk too much. But in talking, when I'm wrong, you correct me. And I never make that mistake anymore. So, sir, over to you.
Okay, before Mr. Wilson will actually go further,
give time for him to think, you know.
No, not that. That particular project, I think I sent you something related to that as a project for Bond 101.
Yeah.
So it's actually our CI project, and that's what we've been working on. And it's good we are talking about now. So I'm actually trying to do some corrections on the slide.
Yeah.
So from this discussion, I might pick out 1 or 2 valid points to add on our presentation against tomorrow.
Good, good. I'm very glad because this is the point, you know, to increase our knowledge in this session.
Yeah, yeah, for the
Wilson from Israel.
yeah, for the drip, there were some issues. The initial design for that project could not go through. It says that the materials, they could not get them to use for the initial design, and pressure was now mounted on the company that they have to deliver.
Yeah.
So 1 month, 2 months, 3 months, 4 months, they just a kind of, oh, let me just give them whatever I have. And that is where the problem started.
So the problem is in the project, right? The project start in the wrong way, right? They put
yes,
maybe the wrong materials and the wrong drip line to deliver what they're expecting, right?
So, and also the plantain, you know, is a complex kind of crop. It's not like maize because of the suckers that you might put it in the station before you know it, it will spread to so many places, and the diameter of the comb will be so expand in such a way that the drip will not be able to fix properly. That is another challenge we are having there, because the same drip we have in the D block near our demonstration is working effectively. We use it for cassava, we use it for maize, even capping. And I think Peter, is not here again, to testify. And of course, the design of the plantain is inline, while the one we have there is not. And so that one is actually giving the quantity of water as expected, 4 liters per hour. So I think the plantain, of course, yes, I agree that the design. Then another issue we are having there also, the storage is not adequate to actually take care of the whole water distribution. So as he said, we are working on it, and we have therefore recommended that more storage, the storage capacity should be increased so that we can have more of the water. And the designer also told that it should be a continuous flowing. That is, once you start to give the water to the feed, the flow should continue. It's not just you feed the underground tank and that is all. It will not reach anywhere. So the constraint also, what we are getting from the FMS, that is the people who are controlling the water, we don't have control over them. They just give us what they feel they can give.
Yes.
So that is why we are now recommending that we should increase the number of tanks so that we can always store the water. Then by the time we open, then the water will continue to flow. I think.
So maybe you can see that in this field we need more water, right? If you have the correct moisture content of the soil that you need to put for all the crops, maybe you can see that another crop is receiving more water. So this is important for you to manage as well, right? If you have the points that you need, maybe you can save some water from this place and put more in this place that's needed, so you can balance, right? I saw that maize was receiving a lot of water. Some cassavas in the field, I don't know if it's the same plot or not, but it was much more water than they need. That's why it was quite slow, right? But I want you to pay attention to this filter parts, huh? From, I don't know if it's the same from this part of Africa, maybe you can help me, but in the other side of Africa, nobody pay attention to filters. And it's a really important component. So do you think it's the same here? Like they are using the correct filters, they are using filters to start, and how this can influence in your irrigation?
Yeah. First of all, the first thing that we work through the designs is the source of water, okay? And when we're talking about the source of water, if it is running water or if it's still, okay, is there, what type of soil is under this water, okay? This is quite important as well. Is there fish around? This is important as well. Is there are there trees around? Okay, will it be filled with organic matter? All of these parameters that we need to understand before we start considering the filtration systems. Okay, the filter system also capacity. One of the things is, yeah, we start pumping from the riverbed, for example. Yeah, we have the strainers there. Okay, and that's it. How can we actually irrigate with water that's full of organic matter, full of zooplankton, full of even soil granules that are swimming in the soil, in the water, okay? Disturbed water, and we're pumping it with with high confidence that, yeah, this is working. If it doesn't flow much, I'll increase the pump capacity. Really? No. The pump capacity is built with a certain margin to provide your field with your water requirement as per your irrigation interval. The filter system is there to be after you pump water to a reservoir. And if you are using water directly from the water source, such as a riverbed, such as the catchment lake, you need a high capacity filtration system for your network. Otherwise, your system is going to be clogged and you will face issues with your irrigation system, be it sprinkler, or even for especially for drip lines.
I think it's very simple. Or you clean the filter, or you clean all the holes in your drip line or all your sprinkler. If you don't clean the filter, you have less water in your field. It's really simple. So usually the people take out the filter or don't put the filter because it's really easy for you to see if you're cleaning or not. So your operator just like, you don't need this. Because in the drip line, it's a little bit difficult for you to see if it's clogging or not, or you take more time to see that. But if you go every day for your filter, you can see if it's clean or not. And if it's dirty, your filter is good because they are doing the correct job. Of course, cannot be block the filter. But if it's some dirt in the filter, it's good. They're doing the job. So if I have an advice for everybody here that wants to improve the irrigation, start for the filter. Check if your filter is good. We have a summary here, as Amir told, right? You have different kind of dirties in the water, right? So you have different kind of filters that you need to use. It's simple, huh? Depends of your size of the filter. Maybe it's quite expensive, but worth it. You save a lot of money in your irrigation system. You save your lifetime your pump, you save your drip tapes, and you save their sprinklers. You save the data, of course, right? The result that you need. So just take a look. The have summary is for you to use. And any difficult, just call me, call Amir. We can come here, we can visit your station, we can advise, we can do everything that you need to support you, okay? And you have pumps more, right, Amir? Sorry, we are run off the time. So we have the pumps as well, the two kind of pumps, and when to use, advanced and advantage. Go one more. Type of pipes, you have different types of pipes, right? And I think this is all the main parts. This is the summary of the summary of the summary that you need to know when you irrigate the system. You need to be the expert. It would be really nice, but you don't need it. You can consult your material. It's really easy to handle it. And if you are seeing the problem and you don't know how to solve it, you did the worst part. That's identify what's your problem. So after you know that you're having clogging your drip lines or the pump is not working, anything, you just can contact us and we'll help you with the solution. Amir, I think we told about this, right? Of course, the maintenance, if you don't maintain your system, you will have heterogeneity in your irrigation and your data, right? And we will bring some trainings, I guess so, right? Amir, maybe you can send in the next few weeks, we can set up the training to determine how you irrigate your fields. And go one more, Amir. And I think this is a really important thing, the standard operation procedure. So someone has some procedure for irrigation system in the station. It's good that we can share. Do you have someone here, Wilson, some procedure for irrigation? Zero. Do you have gift there in Lusaka? Some procedure for irrigation? No, right? Anyone? So I think it's a good point of start. Huh? I really like the procedure that's not a book. That's just based in the quality checks and to solve the problem. So the idea here is for us to build together standard operation procedure. And we are coming later with the bond. So some of the projects in the bond is to build the SOP for the drip lines. So in the afternoon, I will give you a little bit more details about the procedure of irrigation system, who is doing, and you're more than welcome to join us. It's in Simit in Kenya. They are delivering, and I think we can copy and paste for everybody because more or less is the same. So it's a good point of start. I just want to agree with everybody here that everybody must be involved and must be interested to do that because it's a really important point. And to finalize, we need all this point to do a good irrigation system. Huh? We need a good operation. That means we need SOP and a training team. So the SOP, we are trying to develop in Kenya to maybe copy and paste for everybody. Of course, we have customized parts, right? But this will be a little bit easier with the point at start. Train team, we are using bond as well. We have maybe 2 or 3 topics to give training for you guys, and really important you to put the team to listen to us and to be trained, right? We need field management as well. Like when you centralize all your operations, a little bit better and easy for you to facilitate. One has someone responsible, as you commented before. It's really easy for you. I have irrigation problem. I go to this person. So when you centralize, this is very good. Of course, I always see the health and safety environmental, right? We need to check. We are talking yesterday about it. A good maintenance is really important to keep your system going. Planned and focus in quality and improvement. We are talking about improvement of filter and how to check, right? So we need to keep an eye on that. And continuous improvement. This is always important. You see the problem, you don't just fix it, but you need to improve for this problem doesn't happen again. So if this is the last slide, Amir, I think if someone has some comments, some question, this is the moment.
Yeah, I just want to cover with you the next steps. Okay.
I think we also want to.
Oh, sorry. Go ahead, Wilson.
Yeah. With this, you just discuss about 2 types of irrigation: the drip and the sprinkler.
Yeah.
So, which one will you recommend for EiB-IITA?
I will give the engineer answer. Depends. As we told in the beginning, right? We need to see the crops, we need to see the topography, we need to see for which kind of trials you want to use it. So for EiB-IITA, we have, which is the project, Amir, that you're handling? The irrigation project for EiB-IITA?
EiB-IITA, Ikene and Kano.
Ikene and Kano. So this is Ikene and Kano. Amir is recommend really good projects. And some of them is double, right? It's sprinkler and drip, right?
Sprinkler, actually, no, sprinkler and overhead. Because you are not so happy about drip. We actually, not only personally, technically, the drip system, okay, drip irrigation serves better for your research. Okay, there are certain crops maybe that we require sprinklers, yes, but drip irrigation is more efficient. It is more, let's say, conservative with the water requirement. It is more efficient with the water efficiency or the, let's say, the water consumption. Okay, and I will not say that it is. I will not say there's a disadvantage that it will require more maintenance than other equipment. Okay, but we cannot limit things by saying that, yeah, if it requires more maintenance, no, I want to rest. We can't do that. I think Gustavo wants to comment here.
Okay, good. So just to finalize you, so if you need some advice for a specific area, you just send to us. Huh? It's difficult for me to say I go for this or for that without know all the parameters that you show here. If you need help, just I need something for this specific area. Me and Amir will help you.
Hello, sorry.
Yeah, sorry, we have a comment from Gustavo first.
Yeah, so I would like to comment on your question, Wilson. A research station. Can you hear me?
Yes, yes.
Okay. Yeah, I agree with Amir. The irrigation, the drip system. I mean, of course, you had maybe I'm understanding that you had some challenges with drip. But maybe the cause for that is different than the system. The system works. The system is wild, available, and it's not a. The system is not the problem. Maybe there are other problems that can go to the pump, can go to the many other causes that create this or bad impression to you. But I believe in a research station, especially as big as Ibadan, you need to think in a multiple solution. You cannot only rely on one system. You need to have multiple systems for different uses, different cases. So there is a research station. So you may need to have different demand. We may thinking, for instance, in some specific diseases that you cannot really have, or especially go to, for instance, maybe a sprinkler is easier to monitor some type of disease than is in drip, etc. So I recommend for a big station as Ibadan to have a multiple system, not one system. Yeah, but in any case, the most important thing that you need to do to have as a station is the plan. You can't do like, hey, now let's change here, let's change that. And I've seen, for instance, we have one station in Mexico. The breeder came to EIB, came to me and said, hey, Gustavo, we had really bad heritability on this field. And then we went there to investigate why. And they were sure that the problem was in the irrigation. And in fact, it was in the irrigation. But what caused the problem for the irrigation? And they were saying, we are not happy with drip. And then we went there to understand what's the problem for the drip. The problem was that they designed the system considering one drip line or per row. And suddenly they decided, no, we need to change. We need to install two because we will plant more rows, etc. So they installed two. But of course, when we install two, the pressure is not the same. And then impact the water distribution. And then, I'm not happy. But nobody knew that the system had been designed for one row. They simply add more tapes. Summarizing my what I'm trying to say to you, Wilson, you need to have a strong plan for the irrigation system in your station. And design the system and you don't need to implement all the system at one time, but you need to have a plan. You need to. This is what we need to do. and then go step by step. Oh, now we have budget to implement this part. And then, okay, so go to the next step. So don't go like pieces. Pieces will always have problem. We will have problem for maintenance. We have problem for water distribution. And you never find the reason, because can be many reasons for the problems. So anyway, yeah, sorry again. I like to talk too. I think that you realize that.
Thanks, Gustavo.
Gabriel, you have the last comment for us?
Yeah, what I wanted to say is actually from what is practicable here in Ibadan. If you notice, during dry season, we carry out irrigation services, and in doing so,
someone want to comment too? Huh?
yeah, sorry about that. So in doing so, like I feel what Gustavo said is actually right. We have to have combination of system, not probably scrapping out one for one, because for you to prepare your land in dry season, it must be saturated. So how do you achieve that? You can't achieve that with your drip system. It has to be either overhead or sprinkler system. So I think combination of the two will actually go a long way. Thank you.
Thanks, everybody. I think Amir put some next steps for us, right?
Right. I guess just gonna go over them, and if you have any other comments regarding that, please share them with us so that I can record them. So for the next steps, we need to improve how we define the irrigation demands. So, okay, so now we understand what parameters we have. Okay, so we can define them better. We need to continuously update on our water resource availability. So we will have to get this data. Okay, we don't have to wait until we need to redesign. We have to have this data on yearly basis for us to be able to calculate on yearly basis what water requirement we have. Assigning oversight specialists. This is important for all sites. Okay, so need oversight from an irrigation engineer or a specialized person to work on this. Continuously and correctly working on the water requirements, which we just mentioned. Be more scientific with respect to irrigation scheduling. We cannot go just haphazard and just apply for like 4 hours in the field or 5 hours in the field without any calculation or any regard to the soil moisture requirement, etc. We need to integrate the soil moisture sensors. Develop and follow SOPs, and here we mentioned develop because the SOPs must be something that not only we abide by, and we cannot just adopt any SOP. We have to develop something specific to our sites, and we have to do this together. Work on the maintenance of systems. Share the knowledge. Okay, we are here sharing together our knowledge, and this is how we can provide or we can establish the community of practice. So it's very important for anyone who has the knowledge to share it. Okay, spread the awareness, work on following correct procedures, make sure to calibrate and check your systems regularly. If there is anything missing, just let us know and we'll add that. Okay.
Something that just came up to my mind concerning one of the experience that I met. There was also one farm manager who used to irrigate. It was this high-rise sprinklers. Yeah. So what you normally do is you put a rain gauge underneath these movable rain gauges. How efficient is that for someone who is doing it at a large scale or on a research station? Is it a route to take, or it was a bit too extreme?
Sorry, I'll catch that.
Yeah, because we have a project.
Basically, we have the weather stations that we are investing in. Okay, and this will provide readily available data. Okay, on daily basis. Oh, just to calculate on. Okay, just to calibrate. Yeah, this is quite important. It's very, very efficient, but there are many ways to do things. Okay? There are cheap ways, there are expensive ways. That's just it.
Yeah. The expensive way is about pressure, no? You check the pressure and then you see the.
Gustavo, you wanted to comment again?
Sorry, Amir, I forget to lower my hand. So, but when you in the actions here, next step, improve how we define the irrigation demand. I mean, this is, I would put this as the first priority. This is key. And can you hear me well? Is that okay?
Yeah, we can.
I can hear an echo, but anyway, so what I was saying is this is the first priority, in my opinion. Really have a clear understand this in the below the scientific. I mean, this is a science. We are a research station. We sell that, and we need to walk the talk. And I believe that management of the demand for or irrigation for nurseries, for seed production, whatever, should be under the operational team to define the demand. It's just a matter to balance the water demand, etc. Breeders, in my opinion, should define only if it's needed for something specific like drought screening. Beside that, is irrigation is a matter of management and skills. What I'm saying is not because the breeders understand the crop that they understand the water demand for the crop. So I think that, and go to this specialist. So maybe an irrigation specialist is also important. But anyway, comments. Okay, thanks, Amir. Good discussion. Yeah.